Hey everyone, in this video, you learn how to use a new AI state machine. So previously, we were using a hard-coded state machine for controlling the AI, but now we have switched to a data-driven state machine where the states and the transitions between them can be defined from a visual editor. So we look at how it works and how you can use it to create custom scripted behaviors for the AI. So let's get started. So first, let me open the AI state machine window. So I'll go to Tools, FS System, and I'll open the AI State Machine window. All right, let me dock it over here. So right now it doesn't have any state machine selected, but if you just select one of the enemies from a demo scene, then it'll show the state machine of that enemy. Okay, so this is a hierarchical state machine, which means each state can have other states inside it. So for example, here we have two states, ambient behavior and combat. If I double click and open ambient behavior, here we have other states like idle, patrol, follow and all inside it. Okay. Similarly, inside combat, we have two other states, and I can also go inside another level and there are states inside that. Okay. So it's pretty similar to our animator controller. So Unity's animator controller is also a hierarchical state machine where each state can contain child states. And we intentionally tried to make the UI similar to Unity's animator controller so that it'll be easy to use for Unity users who are already familiar with the animator controller. So each box over here is a state and the line between them is a transition. So here we have ambient behavior and combat. So just to give you a basic idea, let me explain how this works. So from any state, if a target is set for this AI, then that AI should go to the combat state, right? If the AI has a target, then that AI should go to the combat state. All right. So by default, an AI will be in the ambient behavior state, which is just another name for idle. And if the AI sees a target, then the AI will switch to the combat state. Okay. So you don't have to learn how to build the state machine from scratch. Our system will automatically build it when you create a character from the FS system setup window. So from here, if you select shooter, swimming, and melee, then it'll add the states that are needed for melee, shooter, and swimming automatically. All right, you don't have to create this from scratch, but I just wanted to give you a basic idea of how the state machine works. Okay, so if you run the game, and let me just minimize the game window, and if I select an enemy, here the current state that is running will be highlighted in blue. Okay, so right now this enemy is in the ambient behavior state. Okay, but if I go in front of that enemy, then that enemy will go to the combat state. All right, and just like animator, you can also turn on the auto live link and it'll automatically go to the state that is currently being executed. Okay, so this will be really useful if you want to debug some AI behavior. You can exactly see what's happening by looking at what state the AI is currently running. All right, so in the system, everything is data driven, and let's say you want to create another AI that will just flee from the player instead of fighting. When it detects the player, then all you have to do is replace this combat state with the flee state. We have actually included an example for it. So if we go to the demo scene, there's a non-combat NPC. And if you select this AI, here the AI will go from ambient behavior to flee if the player attacks him. Okay. So yeah, this is how the system works. So let's try creating a new AI character and see how the AI state machine will be generated for it based on the FS systems selected. So let me just open up a tutorial scene. All right. So in the scene, we just have an environment and a player. So let's go ahead and create an AI character. So I'll open up the FS system setup window. And from here, we want to create an AI character. And let's say we want to add melee and shooter functionalities to it. And by the way, let me also assign a different character model so that we can differentiate it from the player. Okay, so this is the character model I want to add. And I'll go ahead and create it. Okay, so what this will do is this will generate a new state machine with both melee and shooting functionalities. Okay, let me just arrange this a little. And here, if I go inside default behavior in combat, you can see that we have both ranged and melee combat. And based on the value of a blackboard key, we'll decide whether the AI should go to melee or ranged combat. Okay, so if we select the AI character, the state machine will be assigned to the AI controller script. All right, over here. And in here, in combat AI controller, we can define the combat type, whether it should be ranged or melee. So it's melee by default. So if we try testing it, let me just place the AI over here. And if we try testing it, you can see that the AI acts as a melee AI. But from the combat AI controller, if I change this to ranged, and if I change the weapon to something like a pistol, and let me also increase the preferred fighting range, and now the AI should act as a shooter AI. And you can see that he's shooting at us. Okay, so these blackboard keys are something that you can set from the code, just like how you set an animator parameter. So right now we are setting this from the combat AI controller. So if you look at the combat AI controller, here we just have to call AI controller.blackboard.set and pass the name of the key and the value. Okay, it's just like setting an animator parameter if you know how to do that. And this is just a string, so you just have to pass it like this as a string. We put it in a static variable just to keep it organized. Okay, so the reason why I showed you this is because you can customize the AI in any way you want by using blackboard keys. So we're not going to go too much into customizations in this video. You can explore that on your own. But let's look at how you can implement basic AI behaviors like making a patrol or making them play a scripted behavior, etc. So let's say I want to make this AI patrol instead of just standing idle over here. So for that, we don't have to make any changes in the state machine because we already have a patrol state over here. So if you assign a patrol a set of waypoints in the patrol waypoints key, then the AI will automatically go to the patrol state and patrol through the waypoints. So to assign patrol waypoints, we just have to go to the AI game object and add a script called patrol settings. All right, and we'll be able to add waypoints over here. So let me just show you an example. So from here, I'll just search for the waypoints prefab. Okay, let me drag and drop it over here, and I'll turn on gizmos. All right, so I just need 2 waypoints here. Okay, and let me place the second one over here. All right, so now we just have to assign the waypoints to the patrol settings script. All right, so now when we run the game, the AI should patrol through those waypoints. Okay, so we already have a patrol state in our state machine by default, and another state that we have by default is the follow state. So to make an AI follow another character, all you have to do is go to the target handler and assign a default follow target. And from the ambient behavior state, if a follow target is assigned, then the AI will automatically switch to the follow state. Okay, we don't want to do that for the enemy characters, but we can do that for ally characters that should follow the player. Okay, so up next, let's look at how to add scripted behaviors. So in most games, the enemies won't just stand still or patrol through some fixed points. Instead, they'll interact with the environment and other NPCs and all that by playing custom animations. So if you look at AIs from games like Hitman, you can see that they'll be talking with each other or performing some custom animation like smoking or speaking on mobile, etc. So that's how they make the AIs interesting. So how can we implement that in our system? So let's try to implement an example scripted behavior. So I'll just create a duplicate of this AI. All right. And let me just place him somewhere over here. I'll hold Control and Shift and place him so that he will snap to the ground. Okay. So this is the AI on which we'll implement the scripted behavior. So for this AI, we don't want it to patrol. So we can remove the patrol settings script. Okay. And I'll duplicate this AI again and I'll create another one standing over here so that in the scripted behavior, it feels like two AIs are having a conversation. So the example scripted behavior I want to implement is, I want this AI to walk towards the other AI and say he's going upstairs and then go upstairs. So how can we implement that scripted behavior? So you might be thinking we can create a separate state for the scripted behavior in the state machine of this AI and execute that state, right? But that's not the right approach. The problem with that approach is we'll have to create a separate state machine for this AI character, since only this AI character will have that specific scripted behavior, right? The problem with this approach will be obvious if you have 10 enemies in your scene, all with different scripted behaviors. So in that case, if you try to implement scripted behaviors inside state machine, you'll have to create 10 different state machines for the 10 enemies, right? So we should not modify the state machine for creating simple scripted behaviors and all that. Ideally, you should only have one state machine per AI type. So for example, you should have separate state machines for melee AI, shooter AI, non-combat AI, and all that. But we should not create a separate state machine for an AI just to add a simple scripted behavior. So the question is, how can we make an AI perform a scripted behavior without modifying its state machine? So the execute behavior state allows us to execute simple behaviors on our AI without modifying the state machine itself. Okay, so these behaviors will be defined in the inspector of the AI and not on the state machine. And in the state machine, we have three different slots for executing these AI behaviors. One is intro behavior slot, another one is the author behavior slot, and finally we also have a slot for overriding the idle behavior. Okay, so you can replace all these slots with a custom behavior and you can make the AI perform that. Okay, so let's define such a behavior on this AI character. So to do that, I'll select this AI character and add an AI behavior script to it. Okay, so for this behavior, first we want this AI to walk towards this one and then say a dialogue and then go upstairs. So to make the AI walk towards here, we can use the move node. Okay, so in here we can define the move speed. I'll set it to something like 1.5 since I want the AI to walk and not run. And then we can also define the stopping distance. I'll just keep it at 1. And finally, we also have to specify the transform to which the AI should walk. Okay, so we'll just create another set of waypoints for that. So let me duplicate the waypoints that we created earlier. Okay, and let me bring it over here. I'll just hold Control Shift to snap it to the ground. So yeah, this is where I want the AI to walk towards. Okay, so I'll select the AI and in the move node, I'll assign our first waypoint. Okay, and once the AI walks over here, I want the AI to say a dialogue. So for that, I'll use the act node. So this can be used to play an animation or speak a dialogue. So in this case, I don't want to play an animation. I just want to say a dialogue. So I'll just play an audio clip from here. So let me find the audio clip. So the AI will say something like, I'm hungry and I'm going upstairs to get something to eat. And then after saying the dialogue, we want the AI to walk upstairs, right? So I'll take the second waypoint. So it's over there right now. And let me bring it over here. Again, I'll use Control Shift to snap it to the ground. Okay. And now let me select the AI and I'll add another move node. And for this one, I'll assign the second waypoint and I'll change the move speed to 1.5. Okay. So right now, this AI behavior is assigned to the authored behavior slot. So you can change it to intro behavior or idle override behavior if you want. So the intro behavior will be performed as soon as the AI is spawned. Okay. And the idle override behavior is used to override a normal idle state and make the AI do a different behavior. But for most cases, we'll be using the authored behavior slot. So the slot will be used to execute a behavior when we trigger it. Okay, so we usually trigger it when the AI reaches a certain position. So usually in games, such scripted behaviors of the AI are only performed when the player gets close to that AI, right? But first we'll just try running it as a intro behavior, and then I'll show you how to trigger it as an authored behavior. Okay, so if it's an intro behavior, the behavior will play immediately when the AI is spawned. So let me just select the player and place him somewhere over here. Okay. And by the way, one thing I forgot to add is since we want the AI to speak a dialogue, we have to add an audio source to our AI game object. Okay. So let's try testing it. So yeah, you can see that the AI is performing the behavior.
I'm bored of standing over here for so long. I'm gonna go up get something to eat.
Okay, the AI will say that dialogue and then walk upstairs. All right. And by the way, when the AI is running a behavior, you'll be able to see it in the state machine editor. So let me show that. So I'll run the game and I'll minimize the game window and select the state machine editor and then open the intro
I'm
behavior.
bored of standing over here for so long. I'm gonna go up get something to eat.
So yeah, you can see that if you open the intro behavior slot, you'll be able to see the behavior executing. So you'll only be able to see it at runtime because the AI behaviors are created at runtime. So yeah, it'll be pretty useful if you want to debug some AI behavior. Alright, so since the AI behavior was assigned to the intro behavior, it was executed as soon as the AI spawned. But this won't be really useful if the player's starting position is somewhere else in the level because the player won't be able to see this scripted behavior, right? So we only want to trigger such scripted behaviors when the player reaches a certain position. So we have to assign this to the authored behavior slot and we have to trigger it, right? So for that, I'll just use the trigger authored AI behavior prefab that comes with the asset. So this can be used to trigger an authored behavior on an AI when the player enters this trigger. Okay, so let me just place it properly. I'll just place it over here and then I'll place the player here by default. And then here we have to specify the AI on which we have to trigger the authored behavior. So that is this AI. And we have to turn off set target. If that's true, then the AI will detect the player. So yeah, let's try testing this. So when I run the game, the scripted behavior doesn't start by default, but once the player reaches here, it'll start playing. Okay,
I'm bored of standing over here for so long. I'm gonna go up get something to eat.
so yeah, you can see that it worked as expected. And by the way, if you want to make this scripted behavior feel like a conversation by making the second AI talk back, then you can define another authored behavior on this AI, and then you can actually trigger that authored behavior from this AI behavior. Okay, so for example, from here we can set a blackboard value, and then we can set trigger authored behavior to true for the other AI. So if we do that, then as soon as the dialog finishes, we can make the second AI play another dialogue and be part of that scripted behavior. Okay, So yeah, you can use the set blackboard key node to trigger other behaviors on other AI characters. And you can use it to create simple scripted behaviors where multiple AI interacts with each other. So yeah, that's all I want to cover in this video. Thanks a lot for watching, and I'll see you in the next video.